In this question, we encounter a similar problem. We also want to know the empirical formula. However, we have carbon, sulfur, and chlorine in this compound. We know that 10.4% of carbon exists, 27.8% of sulfur exists, but we do not know the amount of chlorine that exists in this compound. We can change these percentages into the amount of grams in the compound as a whole. So we know we have carbon, sulfur, and chlorine. Similar to the last problem, we're looking for the empirical formula. So what we do is add the amount of substances that we have, which is 10.4 chlorine and 27.8 sulfur, and subtract the given amount from 100. So like I said before, we have carbon and sulfur, and we add that, and we subtract that from 100 to find the percent of chlorine. In step 2, we consider that there's 100 grams, and we also know that now there's 10.4 grams of carbon, which was given, 27.8% of grams of sulfur that was given, and we now know the total of chlorine, which is 61.8. Since we now know the total amount of grams in chlorine, we need to transfer this information and find the moles of each of the elements. So we take 10.4 grams of carbon divided by 12 grams of carbon, the molar mass in an actual carbon atom, and we get 0.866 moles of carbon, 27.8 grams of sulfur in the compound divided by the actual 30. So now that we have the 32.06 grams of sulfur, we divide it by the amount of sulfur in grams in the carbon in the compound, and we get 0.8671 moles of sulfur. The last thing we want to find is the amount of moles in chlorine. So we take the 61.8 grams of chlorine in the compound and divide it by 35.45 grams of chlorine in the molar mass. So the amount of moles in chlorine that is found is 1.7433.
So now that we have the moles for each element, we know that there's 0.8666 moles of carbon, 0.8671 moles of sulfur, 1.7433 moles of chlorine. We need to find the mole ratio, and we need to do this by taking the smallest mole value and dividing it with all the elements' mole values. So now we know that it's 0.666 moles, which is the smallest value, and we have to divide it by all the other elements. So we divide 0.666 by carbon, and we get 1. We divide 0.666 by sulfur, and we get 1.00057667. Chlorine, 1.7433 by, again, that smallest value, and we get 2.0116544743. So now we find the mole ratio values from step 4. They're decimal values. We need to round these values to a whole number. Carbon, we know it's 1. We can just round it up to 1. Sulfur, we round it up to 1. Chlorine, we round up to 2. We have those values. The empirical formula is CsCl2.